Hi, myself Kavati Sridhar. I'm working as assistant professor in EC department at Mlritm College, Dundigal. Today, my topic is two-cavity Klystron amplifier in microwave and optical communication subject. So, the introduction about two-cavity Klystron and objective about the two-cavity Klystron. A two-cavity Klystron is a linear beam microwave amplifier that works on the principle of velocity modulation. It converts the kinetic energy of an electron beam into the microwave energy. This is a process of two-cavity Klystron, and we'll explain the operation of two-cavity Klystron later. Now, it is invented by Varian brothers at 1937, used as microwave amplifier. Frequency range is from the 500 megahertz to 30 gigahertz. Its efficiency is 20% to 40%. Output power is several kilowatts. Depends upon the input and output. This is about the diagram of two-cavity Klystron, and its construction is the first one is electron gun, and it is having the cathode and heater, focusing electrode, accelerating anode, and next part is the buncher cavity, input cavity. First resonant cavity receives RF signal and produces alternating electric field, causes the velocity modulation. Next in drift space, the region between the buncher and catcher cavity. No electric field, electrons traveling with the different velocity from the bunches. The next one is catcher cavity. The second resonant cavity, electron bunches transfer kinetic energy. RF output is extracted. The last one is collector. At this collector, collect the spent electrons connected to the positive potential. So these are the construction parts in the two-cavity Klystron. Let us discuss two-cavity Klystron in a brief. This is called the input side, and it is having the two focusing rods here, and it is connected with the electron gun here, and it is connected to the negative side of the potential barrier. Okay, this side is collector side is connected with the positive side. So here in the input side only, the when potential barrier is applied to it, then what happens here, from the electronic gun, continuous electrons will be flows towards the collector side with some velocity, which is having velocity, that is V0. And when this all electrons come to this cavities, first cavity, that is input cavity, and also called as the buncher cavity. And here, when we are giving the RF input to this cavity, some alternating current will be produced in between this gap of this two cavity. So these electrons will affect with the alternating signal, and some of the electrons will be accelerated and some of the electrons will be deaccelerated, and some of the electrons may be as usual. That means a reference some velocity. It is having a reference velocity. So I will explain in the bunching process. So see here, this is alternative current in between the two cavity space, and if the electron hits the positive peak of that alternate signal, its speed will be, at the positive signal, its speed will be higher, and when the electrons hits to this zero level of the signal, it will be reference velocity. It is having the reference velocity, and which is hits to the negative side, that this is called, its speed will be slow. So here, when alternate some signal is generated in between by this RF input. Okay, Then if an electron hits to the positive peak, its speed will be increased, and if the electron is hits to the zero at the zero level, it is as usual as when it is started from the electron gun, and which the electron which hits to the negative side, its speed will be decelerated. That means velocity will be reduced. All these electrons, because of mismatch of this velocity, these are all all are closer together and form a electron bunches. So it is a continuous process here. This all electron bunches are, when it is crossing to the second cavity, that is catcher cavity, when the signal is produced between these two gaps, this whatever, when these bunches meets the positive side, it will get the boosted, and it will be come out through the RF as a RF output in the catcher cavity. And the rest of electrons which are not affected with the alternate signal, these electrons will be collected at the catcher. This is the operation of the two cavity klystrons. When the potential barrier is given to the two cavity klystron, the electron gun continuously giving the electrons towards the collector side, and this alternate signal and these electrons and combine together, and these are generating the bunches, and these bunches are coming out of the RF output at the catcher cavity. So here bunches is first cavities or bunches are produced. That's what is called as a buncher cavity, and second cavity is taking the output from it. So it is called as a catcher cavity. So these are the construction parts of two cavity klystron. Here already I explained, when the electron hits to the positive peak, that is called as the early electron. When the electron hits to the zero level, that is called a reference electron. When the electron hits to the negative side, it is called as a late electron. But here, see here, the time to travel the early electron is very high compared to the later electron. So it is having the high speed and it is reaching to some point. This is a reference electrons. It is also time taken but less than the early electron. And next one, the late electron will catches the this early electron and reference electron at a place, but it is traveling at the very small time. So all together forms the as a buncher electron. So this is called as the drift space. Drift space means the space between these two cavities, and the distance traveled from here to here is the distance, and this is the time taken from the these three electrons. The voltage across gap A, the position of at gap A, and position of at gap A. When see the diagram, at the gap A, at the buncher cavity, the electron bunches are forming. This is the drift space. And at the second cavity, the catcher cavity, we are taking the output, the signal. Here, all electrons are modulating their velocity. That's why we are call it as a velocity modulation. Velocity modulation is happened at the catcher cavity. When the signal enters with the small signal, when a signal enters, it will be amplified like a large. So here signal amplification is done through this two cavity klystron bunching process. Initially, already told you, initially electrons leave the gun at the equal spacing. After the velocity modulation, fast electrons catch slow electrons as they are travel through the drift space. Dense electrons groups are produced. These groups are called electron bunches. That means low speed and reference speed and high speed. These all electrons formed together called as the electron bunch. At the catcher cavity, electron bunches experiences retarding RF field. Their kinetic energy convert into the microwave energy. The advantages of this two-cavity klystron, its gain is high. High gain is 30 to 60 decibels. It is high power output. When we increase the input initial potential voltage, will increase more modulation and more high power and high gain. Excellent frequency stability, high efficiency, low noise, suitable for the microwave frequencies. Disadvantages, large size. It is having the large size and high operating voltage required. Narrow bandwidth requires focusing magnet, bulky compared with the solid state devices. And applications. The applications of microwave two-cavity klystron, the radar transmitters and satellite communication, TV transmitters, and at microwave relay systems, particle accelerators, electronic warfare, space communication, laboratory, microwave sources. For a large distance, we are using the microwave frequencies. So, as we observe, the two-cavity klystron is a linear beam microwave amplifier that works on the principle of velocity modulation. In the entire operation, we have discussed about the velocity modulation, how the electrons will increase their velocity and decrease their velocities and refer their velocity at some with the alternative current. It converts the kinetic energy of an electron beam into the microwave energy. Already we discussed how the operation is done. So this is a overall summary that we are having two-cavity klystron and we are having two cavities, one buncher cavity and one catcher cavity. The electrons gun continuously produces an alternative current from this RF signal will be affected and electron bunches are formed, and these all electron bunches are come out from the second cavity catcher and it is called as a RF output. Here the velocity modulation is happened from gap A to the gap B. So this is about the two-cavity klystron. Thank you.